Unit 5, Lesson 1, Student Example B. In this example, we're asked to find the inside perimeter, the outside perimeter, and the area around the track surface. To find the inside perimeter, we want to imagine that we're going to run around the inside of this track. These distances, they have slide lengths for both the top and the middle of the track of 100 meters. So we're going to have 100 meters on this side and 100 meters on the bottom. To find the inside of the perimeter, we then have 100 on the top plus 100 meters on the bottom plus the distance around one of these circles. So when we look at this, we have a half circle on one side, we have a half circle on the other side. Put them together, we really have one full circle. Now it's showing the radius of this circle as being 20. So if the radius is 20, the diameter is going to be equal to 40. We can use the formula pi times diameter. So to find that perimeter, we have 200 meters plus 40 times pi. 40 pi is equal to 125.7. So we have 200 meters plus 125.7 meters. My perimeter is equal to 325.7 meters. To find the outside perimeter, again, we have 100 meters on the top, 100 meters on the bottom, and then we're going to find that distance around that one big outside of our circle. The radius is 40, the diameter is equal to 80. Our perimeter of this object, 100 meters plus 100 meters plus 80 pi. So my perimeter is equal to 200 meters plus 80 pi is 251.3 meters. So my perimeter then is equal to 451.3 meters. To find the area of the track, we're trying to find the area of the shaded region only. Now to do that, we need to figure out for one big area and then subtract off that small unshaded area. We're going to take that large object and we're going to subtract off this small object. Distance for this entire blue line is going to be 80 meters. We already know our distance along the top is 100. My big area, we're going to have length times width, because that figures out our area for a rectangle, plus one big circle, pi r squared for our area. So to substitute in, our length of our track is 100 times 80. Our radius for our big circle is 40. So we have pi times 40 squared. So our area is equal to 100 times 80 is 8,000 meters squared. Plus we've got 40 squared. 40 times 40 is 1,600 pi meters squared. Now to calculate out pi, we have 8,000 meters squared plus 1,600 pi is 5,026.5 meters squared, and we can add these together, so our area is equal to 13,026.5 meters squared. We have this small area which is 100. Our distance from one side to the other is going to be 40 meters. And then to figure out for our circle, our radius is 20 meters. So to figure out that formula, our area of our small rectangle, length times width again, plus pi r squared. So our area is equal to 100 times 40 plus pi times 20 squared. Area is equal to 100 times 40 is 4,000 meters squared plus 20 times 20 is 400 pi. So our area is 4,000 meters squared plus 400 pi is 1,256.6 meters squared. To combine those terms, we end up with 5,256.6 meters squared. And now we have that big area minus our little area. So we take our big area, which is 13,026.5 minus 5,256.6 meters squared. So my area of my shaded region is 13,026.5 meters squared. So our area for this object is 7,769.9 meters squared.